All right, everybody, welcome to my second episode on Introduction to GDScript or Basic Programming with GDScript, whatever it's titled. And today we are going to be looking at conditional statements. But before we get into conditional statements, let's do a brief revision on what episode 1 had. So these are the various lessons we did in episode 1. We studied variables. And we said a variable is an empty or unallocated memory location where data is stored for further or future use. And there are two ways of declaring these variables. You either use the var or the constants, where the var are for values or are for data that will vary along your programming or as you go ahead, while constants are for values or data that wouldn't change, data you will not alter along the way, because by the way, altering it will lead to a bug. Second lesson, we did the basic data types, where we said there are literally three categories. We have numbers, we have boolean, and we have string. Under numbers, we have either integer or floating point numbers, where integer are whole numbers, floating point numbers are decimal numbers. Bool is simply true or false, and strings are simply characters, list or characters simply. And we declared strings, and we did examples such as adding two numbers and also concatenating a string. We also did basic GDScript operators and expressions, where we did arithmetic operators, where we added two numbers, concatenated strings, and we said concatenated string is simply adding a string to another string. And from what I said, adding, you cannot subtract a string from a string, you cannot multiply a string from a string. So for arithmetic operators, you can only add two strings, you cannot subtract, you cannot multiply, you cannot divide, you cannot find the modulus. So we found the modulus of two numbers. We could tell that 10 divided by 2 will give you a remainder of 0, 3 divided by 10 will give 10 divided by 3 will give you a certain value. So that's simply what this modulus is for. We also did comparison operators, where we said this is strictly equal to, that's comparing a number to another number, or a value to another value, a data type to another data type. And this is saying this data type is not equal to this other data type. So this is the not equal to. We have the less than and we have the greater than, self-explanatory. Less than or equal to inequalities, and the greater than or equal to. We also did logical operators such as the and, the or, and the not. And we said the and makes sure, or the and outputs a true value if and only if both inputs are true. Both conditions are true before the output will be true. The or needs just one condition to be true before the output is true, and the not just converts the state of the operation. The not converts if the statement is true, the not outputs a false, and if the statement is false, the not outputs a true. Okay, so we are getting into conditional statements today, and we have basically three main conditional statements, which are the if statement, the else if statement, and the else statement. We will put all that in practice now. So let's go to Godot. Alright, this is our previous work. I will clean everything, and we'll declare new variables back. We'll start afresh with this program, and in order for me not to be seeing this error, I will pass this function. Alright, so we have our initial extend node 2D, the node to which this script is attached, and our ready function, which is by default, which is what we will be using to execute our code basically, because it runs immediately the code or immediately the node enters the tree. So in our last lesson, we already made use of conditional statements, but we made use just of the if else statement. And I did not explain much about it because I knew we'll get into that deeper in this episode. And basically, the if statement, what it does is it takes, it has its syntax. You have in Godot, you start with the if word, then state the condition for that if. For example, I want to print, let's say I want to print on my console, I want to print you are good to go, and I can print this only if a certain condition is met. Now, what is that condition? I'll come up here and declare a variable, and I will say condition, and I'll set my condition to true, meaning it's a bool. And what would the if condition do? The if statement do? The if statement will check, is my condition true? So condition, if my condition is strictly equal to true, don't forget the quotes, the colon, sorry, don't forget the colon. Now take note, a single equal to is not comparing two values, which is why we do not see it under our comparison operators. A single equal to in normal math compares, yes, but in coding, in any language, a single equal to is initializing, giving a value to a variable, giving a value to a variable. While here now, this is where we compare. We make sure that condition must be equal to true before we print this. If I cancel one equal to, you see they'll give me an error, and the error says assignment is not allowed inside an expression, because yes, as I said, it's assigning a value to a variable, but comparing a value or comparing two variables, we use the double equal to, strictly equal to. So I want to print this if and only if this condition is true. And if I run, obviously it will print you are good to go down here because my condition is true. If I change it to false and I print, it has nothing because the if condition says it must be true in order to print this. Now basically this must not be a true or false something. I can set my condition to, let's say, 11, and I say my condition must be greater than, less than, or equal to 10 before it prints this. If I run, it doesn't print. Why? Because my condition is 11. It's not less than or equal to 10. If I put 11 here and I run, it will print you are good to go because my condition is 11, which is true because the condition is less than or equal to 11. If I put something less than 11, let's say 4, and I run, it's obviously going to print you are good to go. But if I use the strictly equal to here, it must be 11. It can't be less than, it can't be more than, even by a point. So if I put 11.1 or 11.0001, that's already more than 11. If I run, it doesn't print anything because this floating point number after the decimal point makes it 0.00000 times bigger than 11. If I remove this one, it will run because this is equivalent to 11, and our output will tell us you are good to go. It could also be the greater than or equal to. So here I would put 1 again, and run, because that value is obviously greater than 11, and you are good to go. But if I come here and I put 10, although this is more than 10 but it's less than 11, even if it's, let's say, 99999, and I run, that is still less than 11. You don't have it because it's not either equal to or greater than 11. So let's set this back to true rather than using values. True and false is going to, now you cannot say greater than or equal to true. It doesn't, I don't know how, it doesn't even make sense. They might not show you an error. They might not show you an error. If I remove the equal to, they might not show you an error. But let's run and see if it works. I've never actually even tried this, but I know it doesn't, because I don't know. True or false is simply 1 and 0 respectively. So there's nothing like 2 period or -1 or anything. So that you cannot have greater than true. You either have true or you either have false. Now this is the if condition. If you are to use multiple conditions, you say if this condition is true, you print this. Or if there's another condition, don't forget, when I do this, it indents telling me it's a child of if, but I don't want to put an if under an if now. I want to put an else if, or in short, elif. Condition is equal to false. This will not work for what we want to do. Let's use values. Let's use 5 here. Let's use 9, and let's put 10 here. Let's pass this. Let me explain something. What I'm saying here is, if my condition is strictly equal to 9, I should print this. But what if this condition, what if this condition is not met? What would the program do? For example, you saw when we ran, we had nothing here because the program didn't know what to do if the condition doesn't run. So this else if now tells the computer to run this if this condition is not met. So let's say if condition is greater than or equal to 9, you print this. If it is less than or equal to 5 to 9, up to 5, let's put 5, you print not good enough. We are using else if. We are telling the computer, if this condition is met, fine, print this. But if this condition is not met, then this is an alternative. Now let us put 10. Obviously it's going to print you are good to go because it's greater than or equal to 9. And you have it here, you are good to go. If we put, let's say, 3 and we run, it will say not good enough. And why does it say this? Because it is less than 9. It's not greater than or equal to 9. So this condition was not met. It runs the alternative condition. Now what if I put 7? Now 7 is not greater than or equal to 9, neither is 7 less than or equal to 5. What would it print down here? Let us run and see. It prints nothing because the computer doesn't know what to print. You have not told the computer what to print, which takes us to the last conditional statement, which is the else. Small letter, please. Else. Now else, I don't need to give it a condition because what the else statement does is, let's say, prints nothing at all. What the else statement does is, if none of the above conditions are met, then you do this. Meaning if these 2 conditions up here, or if these 100 conditions up here, depending on how many conditions you have, depending on how many else if you have, if none of the conditions are met, then the computer should run this. So if I run now, you realize it prints nothing at all. And why does it print this? Because this condition was not met, neither was this condition not met, neither was this condition met English. And since none of the conditions were met, then we have no choice but to print this. So the else runs if none of the other conditions are met, which is why we don't give it a condition. It doesn't have a condition. It runs if all the other conditions are not met. And this is how the if, else if, and else statement are. If you write a program and you have an if statement, one way or the other, there must be an else statement to end, because there are infinite possibilities, and you cannot handle all those infinite possibilities. And so you tell the computer, if any of these possibilities or any of these conditions are not met, then you run this, rather than being blank. Especially in game development, you cannot leave a blank game. What if the player's life is greater than or equal to 9, he is good to go. If the player's life is less than or equal to 5, he should go and, I don't know, eat or take blood or anything, buy health. If he doesn't do any of these, if his life is less than or equal to 5 and he doesn't go to do this, what should he do? He should die. He is to die. Or you should print a warning. If you don't do the else, especially in game development, if you don't end your if with an else, you must necessarily not have the else if, but once you have an if, you must have an else. So if you don't have an else, your program has a problem. Your program has a problem. So you must have an else. You necessarily must not have an else if, but once there is an if, an else must follow. Because if the player doesn't die, then the player just stands there with 0 life, or maybe his life goes to -1, -2, negative, and that's a bad game. And so these are basically the else if statements we have touched in such a short while. Great explanations. Now, this is another short example of the if, the else if, and the else statement. Now, what this does is we have a player health. We check, is the player's health greater than 70? We print player is healthy. Is the player's health greater than 30 but less than 70? Although it's not put here, but you should know that greater than 30 should be less than 70. We print player is injured. Else player is critical, meaning anything less than 30 will print player is critical. And for now, our player is 45, which is in between 70 and 30, so it's going to print player is injured. Let us run and see. Player is injured. If we put 0 here, or even 10, we will say player is critical. Now, if I want my player to die, if I want my player to be able to die, I will come here. Now, I already have an else statement, so I cannot put another else statement belonging to this same if. Even if I pass, you see there's an error and they say unexpected statement found else, which is why I said you cannot have an else without an if, but you can have. But when you have an if, you must have an else. You might necessarily leave out the else when you have an if, but an else cannot exist without an if. But an if can exist without an else, but it's not advisable. I don't know if you understand what I mean. So if I want to actually print player died, I will have to change this else here to another else if. And it tells us an error because only the else can stay without a condition. The else if must have a condition. And what's the condition? My condition here is if player's health is less than or strictly equal to 0, then if player's health is greater than 0, you write critical, player is critical. Else anything less than or equal to 0 will say player has died, meaning even a -1 will tell you the player has died. So if you run, you have it, player died. Even a 0 will tell you the player has died. If you run, you have it, player died. But if we have a 1, you run, they'll tell you player is critical. So you can have so many else if at the same time. You might not have an else if at all. So I will toggle comment on this, Control K, and if I run, you have player died. And why is player dying? Why is player dying? Because we have said any held below 70 should print player died. Remember, we necessarily don't need else ifs, but we need, once there's an if, there must be an else, and once there's an else cannot exist without an if. So what this condition does is anything less than 70, anything greater than 70 will print this. Anything less than 70 or equal to 70 will print this, meaning even if our health here is 70 and we run, you'll still have player died. So if we want it to start from 70 upward, we will put greater than or equal to 70. So when we run, you have player is healthy. Okay, so the next thing on our list is nested conditions. Now, what are nested conditions? Nested conditions are having more if statements as children of an if statement, meaning having multiple ifs in ifs statements, meaning, for better understanding, let's do it practically. So we declare, here we will declare two variables. You have enemy underscore post for position, and we set it to 10. And we have another variable enemy underscore site, we set it to 5. And we come now under a function and we now give a condition. If enemy position is less than 10, you print enemy up close. And in this same if, not cancelling my indentation, meaning I am still in this same if, alright, meaning, alright, if enemy, sorry, my enemy here is wrongly spelled, which is why I don't see it. Has to be enemy. If enemy site is less than 5, you print enemy sees you. Print enemy sees you. If enemy site isn't less than 5, meaning if it's anything greater than 5, I don't need an else if here, I just write my else. You print enemy doesn't see you. Then I also close this if here. Not actually close, I actually write his own else. I told you must have an else if you have an if. Not that it's a must, but it's not that it's a must, but it's advisable too. So I'll have my else print enemy far off. So this is basically what this code does. If enemy position is less than 10, initially it will print this, meaning we will have multiple displays here. Initially it will print this first statement if enemy position is less than 10. But this same condition will check, is enemy's position less than 10 and is enemy site less than 5? If so, these two statements will be printed. Else is enemy's position less than 10 and enemy's position greater than 5, print this. Else, if this condition here is not met, then none of these will happen. Hence, it will print this. So let's start. Let's start here where this condition is not met. So we leave it as 10. Obviously, 10 is greater than less than 10. So we print, and you see it prints enemy far off. It has just one print because this condition was not met. Since this condition was not met, all the nested conditions, meaning all the conditions under this condition, will not happen because this condition was not met. These other conditions will happen if and only if this condition is true. If and only if this condition is true. So if I put 9, it will check, is 9 less than 10? Yes. It will print this. Is enemy side less than 5? No, it's equal to 5, so it won't print this, rather it will print this. So the two prints we will see on our display are enemy up close, enemy doesn't see you. So if I print, you have enemy up close, enemy doesn't see you. If I reduce this to 2 and I print, you have enemy up close, enemy sees you, because this condition here was met and hence it did this instead. So this is basically nested conditions. In summary, you can have more ifs under here. I could still have an if and give its condition and actually give it whatever it's to do. But for now, I think this is enough for you to understand what we mean by nested conditions. Now I've commented our condition, our nested condition, where we have our if enemy's position, this. Now, how does nested conditions help? How does it help? It simplifies your code. If we were to do these very conditions, we would have done something like this, where you have if enemy position is less than 10 and enemy side is greater than 5, you print this. Else, if enemy's position is less than 10 and enemy side is greater than 4, you print these. And else, you print this is not all to the condition. In a condition like, in fact, this is one of the worst ways to write your conditions. It will make your code long and unattractive and buggy and hard to understand. But if you can make them to be nested conditions like this, it's a lot easier having more ifs under ifs rather than having these logical operators handling conditions. This will simply still run what we ran. For example, our output here was enemy up close, enemy sees you, and that condition was met when our enemy position was less than 10 and the enemy side was less than 5. So this is simply it. If we run, it gives us the same output as the nested condition. This is exactly it here, but it's the worst way to write it. So nested conditions make your conditions a lot easier and human friendly and very beautiful to read. Now the next thing we have to do is ternary-like expressions in GDScript. So ternary-like expressions are simply, let's say, giving a condition, initializing a condition to a variable, or giving the value of a variable to be a condition. Okay, let's do that practically. Maybe you'll understand. So we obviously need our ready function. We pass for now. Let's declare a variable. Let's say player health. Player underscore health. We give it an initial of 10, and we have to print. No, let's not print now. Let's go gradually. I was already going ahead, forgetting that this tutorial is simply for people who have never done programming as well, and also people who are still getting introduced to GDScript. So we have player held there to be 10. In our ready function, we will declare another variable to be status. And this is where the ternary comes in. The ternary, instead of putting a value here, such as, let's say, alive, this is a status. And if we want to print this status, we print in bracket status. And when we print and run our code, it displays alive. But I want the program to be able to check the status from the players held. I could do that in two ways, using the ternary conditions or my simple if statement. Obviously, I can say if player held is less than or equal to 0, then variable status, this is where I'll declare the variable status should be equal to a string which is dead, else, meaning the player, if it's not 0, obviously the player is still alive, else status, which I will still, status should be equal to dead, and I remove this here. Okay, we have errors. Why do we have these error? Let's put sorry, this should be alive. Firstly, this error here is because this print doesn't have a variable known as status, because status is declared here under the else statement and the if statement, and this print doesn't belong to these statements. These variables, I have declared them. These are not global variables. Global variables are all the variables we have declared up here. These variables can be used anywhere in the code, but here I've declared these here and I've declared these here. So this print here is asking, where is the status variable found? And if I want the print to know where it is, I will just indent, and obviously it's reading just the else status, meaning even if I change this to 0 and I print, it doesn't give me anything. Why? He does not understand this condition. This variable status under the if here is different from this variable status under the else. So in order to use one variable to make the computer to understand that these are the same variables, or how to declare it globally. So I'll put status up here and set it. I must not initialize it, but for security purposes, which still isn't important in this course, I'll leave it like that to tell it saves strings. You should not initialize a value to status. Status saves strings. These are strings in the quotes. So I leave it like that to tell the computer to understand that what status can save is a string. So if I come here and I put 0, status cannot read 0 because it's supposed to be a string. It won't show you an error, but you have errors when running your code. So now our print, we must not indent it again. We could leave it here, and if we run, you have dead because obviously it's 0, but we have 1 and we run, you have alive. So rather than having these 4 lines of code here, Control K, rather than having these 4 massive lines of code, there is a simpler way to do it. And that simpler way, what that simpler way does is, I'll remove this variable here. I wouldn't need it up there. I'll need it within my code, and I will declare it status. I can just variable status, and this is where ternary like expressions will be very useful. On one line, I will make the program to understand all these conditions. And what will I tell it? I'll tell it statue will print alive only if player health is greater than 0. If it's not greater than 0, then status is dead. So these, how many lines of code? 1, 2, 3, 4, 5, 6. In fact, 5 hectic lines of code. 1, 2, 3, 4, 5 lines of code has been summarized to 1. This is the use or the importance of ternary-like expressions. They have summarized, they have reduced the number of if statements or have in my code. They have made it very simple. My status will print alive if and only if my player health is greater than 0. So here it's 1, obviously status. We haven't told it to print anything yet, sorry. So print status, and if you run, you have it alive. And if I change this to 0 and I print, you have it dead. So you see how 2 lines of code are summarized 5 lines of code. Make your code shorter and simpler. Let me remove this here so that you see how clean. Look how clean the code is. God, no stress. No stress. So that's one thing. That's one amazing thing about ternary expressions in Godot. We could do this for anything. We could have let's declare a variable button. Let's leave it like this. Button to be equal to true, telling it it's a bool. And we come down here on that function and declare a variable and say bot underscore start is equal to plain if and only if, we haven't given the condition yet, if, no, the condition is actually there, if and only if button is strictly equal to true, else you have paused. So what this then we print, or rather than writing too many prints, you know you can use one print. You can use one print. Cut this here and paste it here. Print. Now we are printing 2 strings, so we concatenate and put bot start. So what this second one does is it's for like a button. If a button is pressed, you set that button to true, and if the button is true, the text on the button should write plain. If the button is false, then the text on the button should write paused. And we have concatenated the strings here, and if we run, you have it dead plain. It's not separated because we need these to separate them. And if we run, you have dead plain. If I put 1 here, you have alive plain. If I put 0 there and I put false here, you have dead paused. So look at how simple the code is. Very simple and straight to the point. So guys, that is basically condition statements in Godot. 40 minutes already so far, so I'm looking forward to seeing you in episode 3. Hold on, hang on, like, subscribe, and share if you want your friends to learn GDScript. And subscribe to my channel for more videos. I am thinking of doing alternative videos. So as I do this series, I will do alternative videos that will handle other things in Godot, maybe coding an actual game and everything. So if my next video might not be the third episode, don't lose hopes. It's still about coding in Godot, and I think you've had a lot of basics to Godot. We still have functions to do in the series, and once we're done with functions, I think you have a lot of basics already in Godot. So see you guys in the next video, which might not be the third episode, but hold on to the third episode, it's coming. And like, subscribe, and share.